Welcome to the North City Pure Water Pipeline Project presented by Red Engineering. Our team consists of Laura Pandoro, Alejandro Corral, Ali Jassim, Noor Samar, Hayal Sumai, Lin Hatsoun, Abdul Abavtin.
In order to decrease San Diego County's dependence on water imports from the Colorado River, the Pure Water Pipeline Project aims to localize a third of the water supply. To accomplish this goal, water from the Water Reclamation Park will be sent to a new North City Pure Water facility in which water will be purified using proven technologies and added to the city's drinking supply. Red Engineering designed a pipeline to convey water from a new treatment plant located off the 805 in UTC to Miramar Reservoir, a span of 8 miles. This pipeline will pump 30 million gallons of treated water per day. It will follow Miramar Road, tunnel under the I-15 freeway, and continue to Scripps Ranch until it reaches its storage.
The North City Pure Water Pipeline will transport 30 mgds of water across varying terrain. The first 7.54 miles of the pipeline will utilize a 48-inch diameter pipe, followed by 0.9 miles of 30-inch underwater pipe. The main equations that will be utilized in this study will be Bernoulli's equation, equivalent diameters, and equations for head loss. All calculated to take into account the different alternatives of combinations that could be used for this pipeline. Upon calculations, it was determined that a 30-inch diameter pipeline would be most suitable for this project.
Steel was chosen as the pipe material due to its high tensile strength, fracture resistance, elasticity, and ductility. Specifically, grade 50 ASTM A572 steel was selected. The steel pipeline will be internally lined with concrete mortar to protect steel against corrosion and significantly increase ring stiffness. It will be externally lined with a coal tar enamel coating, which protects the pipeline from rusting and other threats from the surroundings. Abiding to water agency standards, ASTM requirements, AWWA standards, and San Diego's Clean Water Program's guidelines, the following parameters were determined. Thicknesses for the steel cylinder, concrete mortar lining, and enamel coating for the 48-inch pipe are 0.2 inches, 0.5 inches, and 0.014 inches respectively. For the 30-inch pipe for the trenchless sections, thicknesses for the steel, concrete mortar, and enamel coating are 0.135 inches, 0.375 inches, and 0.014 inches respectively. In the case of specials, thicknesses of pipe fittings are 0.25 inches for the 48-inch pipeline and 0.15 inches for the 30-inch pipeline. Finally, pipe wall stiffness was calculated to be 61,666.7 inch-pounds, and pipe stiffness equaled 29.94 pounds per inch squared.
This is the vicinity map I did through ArcGIS CIP tracking. As shown, our pipeline starts at the North City Water Reclamation Plant, located off the 805 in UTC, to Miramar Reservoir, a span of 8 miles. It will follow Miramar Road, tunnel under the I-15 freeway, and continue to Scripps Ranch until it reaches Miramar Reservoir. To design our pipeline, we used AutoCAD Civil 3D. After using the information from the CAD file on Blackboard where the whole alignment of the pipe would be, we divided the pipe into sections to show each area in detail. This section of the pipeline goes under the I-15 freeway. It is divided into profile and plan view. The profile view above portrays the elevation and stations of the pipe. The pipe will be placed at an elevation of 465 feet using the micro-tunneling method. The pipe will be around 300 feet under the freeway.
This pipe section is on Carroll Canyon Road. After checking the site on Google Earth and checking underground utilities, we picked a suitable lane on Carroll Canyon Road to place the pipe in it. The pipe will be at an elevation of 488 feet and end at an elevation of 510 feet. Section 3 is also on Carroll Canyon Road, crossing Scripps Ranch Road intersection, then entering open land using the micro-tunneling method.
This is another section where we place the pipe in a parking structure.
The deflection of the pipe is resisted by the compactness of the soil at the site. Under the load, it deflects according to the ratio of the modulus of elasticity of the pipe and the soil. The predicted deflection is 3.7%, which is less than an allowable 5% according to the table that we are given. Ring stability is the ability of the pipe to not give away or collapse due to the external pressure on it. Ring stability is analyzed by interaction between the structure of the pipe and the soil. If the ring is unstable, it will ultimately lead it to failure and collapse. The max allowable pressure in the steel of the pipe is 271 kPa. The plot is based on a working pressure for which allowable stress, according to the calculation, which is 271 kPa. Show the graph. The maximum allowable pressure is 165, which is the working pressure.
One of the objectives to achieve pipe installation is to provide an embedment to protect the pipe from mechanical damage, from impact or hard objects in the soil, and to provide support against earth and live load pressures, where this is required. According to the ASCE manual, Buried Flexible Steel Pipe Design and Structural Analysis, the formula is used in dimensionless terms for evaluating maximum trench depth, Z, with parameters including unit weight of soil, cohesion of soil, and soil friction angle. Using those parameters for sandy loam, a depth of 101 inches or 8.4 feet is found using the maximum trench depth formula. Also, according to the ASCE manual, Buried Flexible Steel Pipe Design and Structural Analysis, generally, if the trench wall can stand in vertical cut, it has sufficient strength to provide horizontal support for the pipe in a trench of width equal to 2 times the diameter of the pipe. Therefore, the trench width would be 2 times its diameter, which is 48 inches, which will be 96 inches or 8 feet.
There are 3 types of trenchless design: micro-tunneling, pipe jacking, and horizontal boring. For the pipeline connecting the pure water treatment facility to the Miramar Reservoir, micro-tunneling is the type of trenchless construction that needs to be chosen for several reasons. Micro-tunneling is particularly advantageous for difficult ground conditions without the use of expensive dewatering systems or compressed air. Micro-tunneling is usually used in heavy road traffic, which is what the I-15 is. Also, it is when utility pipes buried underground are congested and difficult to dig from the surface of the ground. In the I-15, it is difficult to dig from the surface of the ground because of the utility pipes underneath the road. In addition, crossing road and rivers, which means impossible to dig from above ground. The project crosses through the Miramar River, which is why micro-tunneling is the best option for the project. Cobbles and boulders can make excavation difficult if not planned. According to the facility design criteria of San Diego, micro-tunneling can handle boulders and cobbles obstructions 1/5 to 1/3 of the diameter of the cutter head, depending on the type of cutter head. Since the I-15 has boulders with a size of 1/5, micro-tunneling should be used. Micro-tunneling machines are typically equipped with eccentric cone-type crushers or jaw crushers.
The last 4,000 linear feet of alignment were analyzed for compliance of the pure water pipeline with city and state separation requirements. Maintaining proper distance between water mains and other utilities is crucial to prevent soil and groundwater contamination in case of a pipeline rupture and to protect nearby mains. The most important standards require a minimum of 10 feet horizontal separation and 1 foot vertical separation between mains. Under Carroll Canyon Road, existing pipelines underground are too close together to install the pure water pipeline 10 horizontal feet away from others. The horizontal separation was determined to be 8.5 feet, the furthest part as possible. To increase protection and increase safety in this portion, a continuous sleeve will cover the pipeline under Carroll Canyon Road. The majority of the remaining 4,000 feet of alignment are areas where the pure water pipeline comfortably abides by standards.
So in conclusion, Red Engineering used an array of engineering disciplines to find a solution to successfully transport 30 MGDs of water from the North City Treatment Facility to the Miramar Reservoir. Utilizing disciplines such as geotechnical engineering, civil engineering, and hydrology, we were able to construct a plan that best fits the design criteria of our agents.